All right, so today we're going to talk about something really fascinating happening in AI right now. It's this huge push for incredible speed, but it turns out that speed comes with a pretty serious kind of hidden flaw. Let's get right into it. You know that feeling, right? You ask ChatGPT or some other AI a question, and you just sit there and watch it type out the answer, one word at a time. It can feel like it takes forever. Well, there's actually a really specific reason for that, and it's a huge problem that everybody in the AI world is trying to solve.
And that whole slowdown, it all comes down to what's been called AI's one-word problem.
So pretty much all the big language models we use every day work on this principle called autoregressive decoding. The easiest way to think about it is like a super careful writer. It writes one word, then it stops, thinks, and picks the next best word based on everything it just wrote, then the next and the next. It's very logical, it makes sense, but it's also the fundamental reason these incredible AIs aren't lightning fast. It's a bottleneck. So, if going one word at a time is the problem, what's the solution? Well, there's a new idea that promises to just completely shatter that speed limit. Say hello to a new kid on the block. Diffusion LLMs, or DLLMs for short. This is a whole different way of doing things. Instead of writing one word at a time, they're built for what's called parallel decoding. They can generate whole sentences, even paragraphs, all at once. I mean, this is the big promise, right? A massive, massive jump in speed. And this slide really lays it out perfectly. On one side, you have that careful writer going step by step. On the other, you have the speed typer, just blasting out whole chunks of text at once. This sounds amazing, right? All the smarts of an LLM, but basically instantaneous. But, as you might have guessed, there's a catch. And this is where the story takes a really interesting turn. Turns out that amazing new speed comes with a hidden cost, a real glitch in the system. So the glitch has this really technical name, the conditional independence assumption. I know, it's a mouthful, but the idea behind it is actually pretty simple. To go that fast, the AI has to pretend that every word it's generating at the same time has nothing to do with the other words. It basically becomes blind to the connections between them, and this is where things start to go wrong. Let me show you a perfect example from the research that just nails this point. An AI is given a really simple job. Just pick a city from a list that has names like New York and Mexico City. Simple enough.
So because it's generating in parallel, it's looking at words on their own. It sees the word new and thinks, hey, new shows up a lot on this list. That's a good choice. Then it sees the word city and thinks, yep, city also shows up a bunch. Another great choice. On their own, they both seem like solid picks.
And so, what does it do? It spits out new city. It just mashed together two words that looked good individually but make no sense together. It completely missed that new has to go with York. And that, right there, is the hidden flaw of going super fast. Okay, so that probably makes you wonder, if this flaw is so obvious, why haven't we seen it everywhere? Well, it turns out, to really prove it exists, researchers had to build a special kind of AI stress test. The reason this problem kind of stayed under the radar is that the usual tests we run on AIs, they're mostly about math problems or writing code. And for those kinds of tasks, the specific relationship between one word and the next isn't nearly as important. The tests just weren't built to find this particular weakness. So they created something called Parallel Bench, and I love how they thought about this. It's not just a test, it's a custom-built obstacle course. It's full of these little traps that are super easy for a person, but are specifically designed to make a parallel decoding AI trip over its own feet and expose that core weakness. So what's in this obstacle course? Well, you've got three main areas. Waiting line tasks are all about logic, like shuffling a list of names without repeating or dropping any. Text writing tests, basic stuff, like can you make a grammatically correct sentence? And puzzles test things like Sudoku, all things that depend heavily on the relationship between the pieces. So the big question is, what happened when they put these super fast diffusion LLMs through this custom-built obstacle course? Well, the results? They reveal this incredibly dramatic trade-off between speed and quality. Okay, first up, let's look at a really easy task. Just copy a list of names. And as you can see, it doesn't matter if the AI generates one word at a time or speeds up to 32, the accuracy is perfect, pretty much 100%. Makes sense, right? It's a simple task. But what happens when we make it just a little bit harder? Now look at this. The task is to shuffle that same list.
When it's working slowly, one token at a time, it's perfect, nearly 100% accurate. But look what happens when we dial up the speed. At just 8 tokens at once, accuracy plummets to 40%. And if you crank it to 32, it's zero. Absolute zero. A complete and total failure.
And this is the whole point. This is the big takeaway right here. The speed is real. You can absolutely make these things faster. But for any task that needs the AI to actually understand how words connect to each other, the quality can just fall off a cliff. It basically means you can have a fast AI or you can have a smart AI. But right now, you can't have both.
And hey, don't just take my word for it. The researchers who did this work said it themselves. They said their findings show a pressing need for totally new ways of doing this. The current methods force us to choose between an AI that's fast and an AI that's actually correct. Which really leaves us with the next huge challenge for the entire field of AI. We've figured out how to make AI incredibly powerful, and we're getting really close to making it incredibly fast. But the next great hurdle, the one this research just puts a giant spotlight on, is figuring out how to make it fast and smart at the exact same time.